Look at a photo of an astronaut floating inside the International Space Station, and something in your brain quietly insists on an answer. Which way is up? You'll find yourself tilting your head, trying to orient the picture, as if there's a correct way to hold it. There isn't. But the real reason is far stranger than simply floating in zero gravity. Up and down were never properties of the universe. They were something your brain built, using a single reference point you've had access to since before you could walk. Here on Earth, up and down feel like fixed facts. Drop something, it falls down. But the physicist Isaac Newton uncovered what was actually happening. Gravity isn't a force that points downward. It's an attraction between any two masses, pulling them toward each other's center. Down isn't built into space. Down is just the direction toward the nearest large mass.
Stand anywhere on Earth, and down points toward the planet's center. Someone standing on the opposite side of the globe has a down pointing in the exact opposite direction from yours. Their up is roughly your down. Neither of you is wrong. Here's the part that reframes everything. Earth didn't create up and down. Earth's mass created one extremely strong local reference point, and your brain built an entire coordinate system around it without you realizing it. Now take that reference point away. Astronauts aboard the space station are often said to be in zero gravity, but gravity is still doing almost all its work out there. What's actually happening is constant freefall, the station and everyone inside it falling toward Earth together, which cancels out the sensation of weight entirely. Without weight pressing you into a floor, the reference point your brain always relied on simply vanishes.
The physiologist Ashton Graybiel spent decades studying how the vestibular system in your inner ear responds when gravity's steady signal disappears. His research helped explain why astronauts often experience disorientation during their first days in orbit. The organ that spent your entire life reporting which way was down suddenly had nothing reliable to report. Astronauts describe adapting in strange ways. Many say their sense of up quietly shifts to mean whatever direction their own head is facing. A ceiling becomes a floor just by flipping your body, and after a few days, it stops feeling strange. This helps explain something else, too. Albert Einstein, building on Newton, described what's now called the equivalence principle. Sit in a windowless room, and there's no experiment that could tell you whether you're sitting still on a planet or accelerating through empty space. Gravity and acceleration feel identical. Up and down aren't baked into the universe. They're simply the local byproduct of whatever happens to be pulling on you.
Zoom out far enough, and the idea collapses further. In the empty space between galaxies, there's no large mass nearby to define anyone's down. An astronaut drifting there would have no floor to fall toward at all, because falling requires something massive to fall toward in the first place. So the truth is nearly the reverse of what your instincts insist on. It's not that space is missing something Earth has. Earth is the unusual one, a single enormous mass strong enough to convince everything living on its surface that its particular pull is a universal law. Which brings you back to that photo of the floating astronaut. There was never a correct way to hold it. Your brain simply couldn't stop searching for the one reference point it's used your entire life, even in a picture where it no longer applied. Look at that photo again. There's still no correct way to hold it. But now, at least, you know exactly why.
For more interesting content like this, subscribe and hit the bell icon.